Good morning everyone. I am Rajini from DBSIT College, Kavali. My branch is ECE and my subject is Electronic Measurements and Instrumentation. Last class I was explained about AC and DC bridge concept. In that I covered DC bridge concept and AC bridge concept. That I covered Maxwell's inductance bridge concept and Maxwell's inductance capacitance bridge concept. Another one is the Anderson bridge concept. Here, why we are used AC and DC bridges? What is the basic concept is we have to measure the unknown resistor, capacitor, inductor. Unknown resistor, inductor, capacitor. So by using this bridge concept, we measure the unknown resistor, capacitor, inductor. Next, coming to the topic, AC bridge concept, we measure the inductance, unknown inductance and unknown capacitance. So there, I prefer here capacitance measurement bridges. So for that, I will take here Schering bridge concept. In this bridge concept, we can measure the unknown capacitor value, and here we can take this is the circuit diagram. For this circuit diagram, I will take here R1, C1 and R3, here C2, R4, C4. What is the balanced bridge condition? The balanced bridge condition is the opposite resistors product will be equal to the opposite resistors product. So that I will write here. So here instead of R1 we having the combination of R1 and C1. Instead of R2 we having the capacitor only C2. Instead of R4 we having the combination of parallel combination here R4 and C4. And R1 place, this is the series combination of R1 and C1. Next, what is the current source here? So this is the internal input signal source and this is the ground. And here we mention the nodes A, B, C and D. And from this node A, the current source is flow, the current I1, and from this node, this direction I2. So I1 and I2. Here I2 is equal to I1. So I2 is equal to I1 by using this galvanic meter, G for galvanic meter. And I4 is equal here. This is the I4. I4 is equal to I2. But I mentioned here the I4 current is split into the capacitor and the resistor. So that's why I will take here IC plus and IR4. So that means here I covered R4 and C4. Next, what is the balanced bridge condition? That is R1 plus 1 by j omega C1. R4 into 1 by R1 plus 1 by j omega C1 into R4 into 1 by j omega C4 by R4 plus 1 by j omega C4. So here this is the parallel of this one R4 j omega 1 by j omega C4. This parallel directly I will take here R4 into 1 by j omega C4 by R4 plus 1 by j omega C4. Here I will write here R4 parallel with 1 by j omega C4. Here directly I will write this in the equation. Next, R1 plus 1 by j omega C1 into, simplify this, R4 by R4 plus 1 by j omega C4. So this is the LHS term and this is the RHS term. Simply we will remember this LHS and RHS. So this is the product of the two opposite resistors, and this is the product of the two opposite resistors. And here I will simplify this equation R1 plus 1 by j omega C1 into R4 by R4 plus 1 by j omega C4, that is equal to, here what are the opposite resistors? R3 into 1 by j omega C2 into, so this opposite resistors product, so this opposite resistors product R4 by 1 plus j omega R4 C4. After simplify this, I will write here R1 plus R1 multiplied with R4. Directly I will write here R1 R4 plus next 1 by j omega C1 into this term. So that is the R4 by j omega C1. So this after simplification, final term is the R4 by j omega C1. So that is equal to R3 by j omega C2 into R4 by R3 into R4 by 1 plus j omega R4 C4, where R4 cancel. Finally I will take here j omega R4 C4, common the term R3. Then final term is the R3 by j omega C2 into 1 plus j omega R4 C4. After simplify this, R1 R4 plus R4 by j omega C1, R3 by j omega C2 plus R3 R4 C4 by C2. So here this is the final equation. For this final equation, you will take here equating the real part will be equal to 0 and equating imaginary part will be equal to the 0. So here what is the real part? R1 R4 LHS side. So in the RHS side R3 R4 C4 by C2. So then from this equation R1 is equal to R3 into C4 by C2. So both sides R4 will be cancelled. So this is the R1 value. So unknown, measure the here resistor value. So or we can take the capacitor, we have to take the capacitor value also, or we can measure the C2 value or C4 value or R3 value. Next, equating the imaginary part will be equal to 0. So from this, what is the imaginary part? From LHS side R4 by j omega C1, that will be equal to R3 by j omega C2. So both sides j omega will be cancelled. Therefore, C1 is equal to R4 by R3 into C2. So here we measure the unknown capacitor value from this Schering bridge. Next, the unknown capacitor, measure the unknown capacitor. Another bridge concept is the Wein bridge concept. So by using this circuit, we can take the Wein bridge. And here the combination, this is the parallel combination of R1 C1 and here series combination of R2 C2, and we can take R3 and R4 terms. First you remember the nodes A, B, C and D. So all bridge concept is connected through the galvanic meter. So G, and here what is the balance bridge condition is the balance bridge condition is, so the two product of the resistor, opposite product of the resistors will be equal to the opposite resistors product. So this R1 parallel with 1 by j omega C1. So this is the parallel combination into R4. So this is one combination. So this is the one combination, that is LHS side. So you remember here this is the LHS. What is the other combination? This is the another combination, that R3 into R2 plus 1 by j omega C2. So from this equation you will simplify, then you will get the R1 R4 by 1 plus j omega R1 into C1 is equal to R2 R3 plus R3 by j omega C2. So here we will take the, after simplification, R1 R4 into j omega C2 is equal to R3 plus j omega R2 R3 C2 into 1 plus j omega R1 C1. So the equating the real part and imaginary part, here the imaginary part having the, this is the imaginary part, and we can equating the real part will be equal to 0. From this R3 plus j omega square R2 R3 C1 C2 R1 will be equal to 0. After simplify this, omega is equal to 1 by R1 C1 R2 C2. That's why we have to consider in the Wein bridge concept, we obtain the frequency also. We obtain the frequency. So we have to take the frequency, unknown measurement of the frequency value. So this is the Schering bridge concept and the Wein bridge concept. Next topic is the interference and noise reduction techniques in EMI and EMC. Here, what is EMI and what is EMC? EMI means electromagnetic interference and EMC is electromagnetic compatibility. Why we are taking these two considerations means this EMI and EMC we have to take in the motors driving system and switching devices. So in the motors driving system switching devices, is there any interference in that devices or in that motor that we have to rectify, and then we can go for the next step. So here this motor driving system, that means we have to take for power supply, and where we can consider the switching devices, it is considered as like some lamps likewise. So for interferences of the electromagnetic interference and electromagnetic compatibility, both we can consider. First we can see the electromagnetic interference. So we can take this circuit. So this is the inductor and capacitor. So here across these two capacitors we can take the load, and here the current sources we can consider this circuit only, and here we can apply the input signal source. So it is used for better supply and better condition. Why? Because of where we can take the motor driving. So in the driving system, if there is any disturbances are there, that will be making a problem. It is a complexity. So that's why first we can find out what is the interference of the system. So when it is giving the better condition, then it will be smoothly we can drive that. So use it for better supply and better condition. And EMI filters causes having two inductors. Its effect something change in the output phase of your sinusoidal. For example, we can take a microcontrollers, telecommunication boards and modules. So in microcontrollers, that will be considered as the devices. So there, if there is any interference is there, the programming, the technical programming will not be developed, then it will be having some problem. So suppose we can take the telecommunication boards. So that board also having any interference, we can't receive the direct signals. So we can transfer the smooth signals. So likewise, the interferences are occur in that situation. So it is the EMI. Next, the another one is the electromagnetic compatibility. Suppose we can take this is the back converter. For this, the signal we can consider for common mode noise or differential mode noise. Suppose we can take this back converter. Suppose we have to take this circuit also. So for this circuit, suppose it is the one. So one line. So it will be internally, it will be going through this, and it will be considered like this. So this is the one way. Or another one we have to take here. This is from this cable we can take, this is the another one. It is considered in the radio frequency system, where that is the electromagnetic compatibility we have to consider. In radio frequency system, in there any interferences we have to find out it, and we can rectify that. So to measure of device's ability to operate as intended in its share. So these two interferences occur in the radio frequency system and in the telecommunication system. Thank you very much.